It's been good. We're still fasting because it's Ramadan, so we've been really busy. Yeah, next Friday, not today. Yeah. Yep, Eid. We usually have a party, so we just have like a whole bunch of food. How's your Easter break been?
Interesting. Okay, cool. All right. So this, you can kind of see it on the screen. This is what the test is going to look like. So there's basically two parts to it. The first part is the elimination substitution part. And the second part is the linear equations part. Oh, Axel joins us. Very nice. The first part of it, there's two multiple choice questions. They're fairly straightforward. And then there's 3 short answer questions as well. One of them's a word problem, but with all of them, I just kind of said you can use elimination or substitution, whatever you feel like using. Use it, go for it. It doesn't matter. I don't care, just solve the question. And then the second part of the exam, hi Axel. The second part of the exam is this linear and quadratics inequalities. So there's 5 fill in the blanks. So it's like a sentence, fill in the blank with the correct answer, blah, blah, blah. There's 2 of them where it's graph the inequality. So 2 of them will look like, they will look like this. So either a straight line or it'll look like graphing a parabola, one of the 2. And there'll be an inequality. You can just graph it, check a point, and see if it's the right answer or not. And then there's 4 questions that are write the solution set. So it's like 1 question, 1 graph. But the 1 question, 1 graph is like this example up here. Where is the example? It's like this one, where I give you a parabola, and then I just ask you to write the solution set for all of the 4 different equations. And all I'll do is I'll give you a greater than or equal to, a less than or equal to, and you'll just write the solution sets. That's pretty much all you have to do for that one. And then there's 2 questions at the end. One of them, and both of them, I don't really care how you solve it. You can use sign analysis, or you can use this test point substitution box. It doesn't matter which one you use. Find the solution, write the solution set, and then that's pretty much it. That's what the exam looks like. As far as things to remember or like good skills to have, one of them would be, can you factor? Do you know how to find your 2 x terms and find your 2 solutions? Another one would be completing the square. So remembering that that's particularly useful when we have an equation that's like y is equal to 3x squared minus 2 minus 6, let's say. If you have an equation like that, you would be able to go like 3 bracket, let's do this, x squared minus 2x, something like that. And then you'd add a ghost number into both of them. So your ghost number would be like divide by 2 and then square. So this would be plus 1. Like this. I can't help but write diagonally apparently with this drawing tablet. And then when you go through to solve it, it would be 3 bracket x squared by Wyatt plus 1 minus 3, something like that. And then you could actually go through and factor this as y is equal to 3 bracket x minus 1 squared minus 3, like that. And that's it. So that would be like one of the questions. Being able to complete the square would be a really nice skill to have. Other things that are helpful is if you know the quadratic formula, that's a helpful thing. if you know how to graph ratchetly, that's a good thing. So estimating what the graph looks like. And then remembering that when you divide or multiply by a negative, you need to flip the sign of the inequality. There's all a whole bunch of different things. When you have, oh yeah, and then these are just reminders that I threw in there. So when you have a greater than or equal to or less than or equal to sign, you need a solid line when you're graphing. When it's a less than or greater than, you need a dotted line. And then this part with the 0 and the y. So if it's equal to 0 or greater than less than to 0, you shade only the line. If it's greater than less than equal to y, you shade the solution region itself. And then test points are sign analysis, and then remembering how to do your solution sets. It's pretty much everything that you'll need to see on the exam. So, Axel and Aska. Welcome, Axel. Hope you're having a great Easter, my friend. Is there anything that you guys would like to go over? Were there questions from the review? Were there things that you want to see again that would be helpful to review and go over?
Can we cover elimination and substitution again?
Sure.
Because when doing the textbook questions, I struggled a lot.
Okay. Let's see. Which method do you prefer, Aska? Do you prefer elimination or substitution when you're solving?
Elimination.
Okay. I definitely prefer that as well. Let's see if I can get a practice question up here. Ooh, yes, Khan Academy. Hello. I can probably make one up too, but I don't like that one. Okay, so let's say that we have y is equal to x squared plus 5x plus 9 as one of our equations, and then the other one would be y is equal to x plus 21. Let's say those are our two equations. So the way that I taught you guys in class was to add these two equations, and what you would need to do is multiply this entire thing by -1. You can skip that step. You can do that step. It's really up to you. If you just put a subtraction sign out in front, I've done this enough with my Foundations 20s that I found often they would forget that that negative needs to apply to everything. And so I started teaching it as addition rather than subtraction, but it also works when you just do subtraction like this. If it's helpful, you can put it in brackets and that works. So y minus y is 0, x squared minus x, well, I can't do that, x squared. 5x minus x would be minus 4x, and then you have 9 minus 21, which would be -12, I think, as long as I'm doing my math correctly. So whenever you eliminate, the next step is always try to factor it. So this would be x minus 6 and x plus 2, like that factored. And then the next thing would be to just write your two solutions. So it'd be like 6 and -2, for example. So when we're doing elimination and substitution, I'm always going to ask you for the intersection of two graphs. So like, if we think about these two graphs, x squared plus 5x plus 9, that graph is up here. It opens up like this. X plus 21 has a y-intercept up here somewhere. I'll do this in red. Has an intercept up here. So what we're looking at is probably a situation like this. So we know that our two solutions so far is we know that this left point is at -2 because we factored that and would have solved it. And then this top point would be at +6 because we factored and solved that one as well. And so now what we have to do is you just have to figure out, okay, what are the y values at those 2 points? I would just use the easier equation, which was y is equal to x plus 21. And all you're going to do is just plug in the two x values that we figured out. So we figured out 6 plus 21 and y is equal to -2 plus 21. So you'd have two answers, 19 and 6 and 21 is 27. So your two answers then would be those two solutions. So we used a x value of 6 and got a y value of 27. We used an x value of -2, got a y value of positive 19. So then you'd have your two answers like that. And if I plug in those two equations into Desmos, I should get the exact same answers. So one of those equations was y is equal to x squared plus 5x plus 9. Okay. And then the other one was y is equal to x plus 21. And you can see exactly as I described up here with those two coordinates, 223, x 615. Probably added something wrong here. What did I add wrong? -6, hey? Oh, this should be plus 4x, so this would be plus, and this would be minus. That's what I did. So literally all of our signs are flipped then. So it'd be -6 plus 21, which is, that would be the 15, positive 15. And then this one would be positive 2 plus 21. So this would be 2, 20, 23, like that. So those would be our two answers. I just forgot one of my signs, or screwed up one of my signs. So this one would be 2, 23. Our 2 points there. That's our 2 points of intersection. Do you want another one, Aska, or is that one good enough?
Can we do one more?
Sure. See if I can find one. Ooh, that one's a tricky one. I like this one. I don't think there's one this hard on your test, but we'll throw this one up at there anyways. So we have...
You said on the test that we could choose either kind, like substitution or elimination, or
Yep.
are we...
Yep, doesn't matter.
Okay.
I put it in words in writing on your test. I made sure that I did that. That choose whatever. I don't care. Just get the solution however possible. So you could not do substitution at all and get away with it completely. Do you want to do elimination again for this one?
Yes, please.
Okay. So in this equation, one of the ugly parts of this is this part and this part here. They're never going to be equal to each other if we want to cancel them out. So what we would want to do is get rid of or eliminate these y's. So for this top one, I would multiply everything by 7. So I'd multiply that by 7, multiply that by 7, and multiply this by 7. For the bottom one, I would choose to multiply everything by -2. And that's so that I get a positive 14y up top and a negative 14y on the bottom. So then we've got two new equations. So 3x squared times 27 is 21x squared. This is 14y. And I don't know what 26 times 7 is at the top of my head. 182. And then the other one is 10x squared. It'd be negative 10x squared minus 14y. -6, like that. So you can add those two equations. Now, in class, what I've done often is moved the 182 and the -6 over at this stage to the other side of the equal sign. It doesn't super matter. You can do it now. You can do it later. Either way, as long as your equation's equal to 0 at some point, you're happy. These two cancel out in the middle, the 14 and the 14. Those two are gone. And then what we're left with over here is 182 minus 6, which is 176. So now, at this stage, now we'd have to go minus 176 from both sides. And we end up with 11x squared minus 176 is equal to 0. I bet you 176... Of course it is. They're both divisible by 11, so you can pull 11 out, and you have x squared minus 16. Ooh, good question. The reason this is a good question is because when you start factoring this out, once you factor the 11 out, you'd think you're done, but this inside is a difference of squares. So it's x minus 4 and x plus 4 is equal to 0. So then we have two solutions for x. Negative 4 and positive 4 would be our two solutions. And so
What chances that you'll put a question like that on the exam?
what are the chances that I put a question like this? Pretty strong. Maybe not the like initial part, but the difference of squares, pretty strong. So that should be a pretty good clue that, like, yeah, there's one on the exam. Thanks for the thumbs up, Axel. Okay, so yeah, and then at this point, it's just like plug in x is equal to negative 4 and plug in x is equal to 4 on both sides of the equation and solve. So I would use, which one would I use? I guess it doesn't super matter. Probably the top one. So 3 times negative 4 squared plus 2y is equal to 26. And then 3 times 4 squared plus 2y is equal to 26. You get the same answer for both, which is interesting. 48. 22. And you should get the same answer for this as well. And that would be, so your two solutions would be negative 4, negative 11. And 4, negative 11. Those would be your two answers for that one. What else do you guys want to see?
Could you walk us through Chapter 8 review, question 8?
Chapter 8 review, question 8. Like the textbook?
Wait. No, the handout sheet you gave us.
Okay. I was like, I don't have my textbook here, so that might be problematic. Yes. Let me just find. You want the Chapter 8 review, hey?
Yeah.
Okay. Let's see which one this is. Question, which one? Sorry, Axel?
8.
Ooh.
Just the word questions,
yeah.
really.
Yeah. Yeah, this is a good one. Okay. Determine two whole numbers such that the first number increased by triple the second number is 24. So let's say x is the first number and y is the second number. So I think this is x plus 3y is equal to 24. If the first number is squared and decreased by 5 times itself, the result is 13 less than the second number. I think those are the two equations for this. So determine two whole numbers such that the first number increased by triple the second number. So increase, this would lead me to believe that we're looking at addition probably. Triple the second means 3 times that second number, whatever it happens to be. And then the second part of this, so we have a break here in information. If the first number is squared and decreased by 5 times itself, the result is 13 less than the second number. So y minus 13. So those would be those two equations. We'd be looking at either elimination or substitution then from this point. And y seems like the only thing we can really eliminate. So I'm going to move everything over to the left. Do you want me to walk through the rest of the example as well, Axel?
Yes, please.
Okay. So what am I doing here? This should be minus y. So minus y minus or plus 13 is equal to 0. I'm going to subtract 24 from both sides on this. Okay, so what I have here is x plus 3y minus 24 is equal to 0. So I've got my y's on the left. This one, I need to multiply everything by 3 so that I have 3y's, negative 3y's, and positive 3y's. So our two new equations are x squared plus, x plus 3y minus 24 is equal to 0. The other one is 3x squared minus 15x minus 3y plus 36 is equal to 0. Those should be the two equations. So then if you add these two equations up, you end up getting 3x squared minus 14x plus 12 is equal to 0. So then as far as our factoring, 3 times 12 is 36. We need two numbers that add up to 14. What would be two numbers that add to 14? Not those two. Wonder if I factored it correctly on this one. Let's see. Which review is that? I would cheat like this and go 3, 14, and 12. And get my two answers like this. 3.53 and 1.13.
Would we have questions like this on the test where we need to use the quadratic formula?
There is one, yes, where you need to. Yeah. You can do it without the quadratic formula, but you're going to be looking at it forever. Because you end up getting a decimal answer. But yes, there is one where you definitely need to use the quadratic formula. This test is big because it's kind of putting together all of the skills that we've been working on up until this point. Like elimination substitution is a big part of the course. And to do it effectively, you need to be able to factor, you need to be able to quadratic formula, you need to be able to complete the square, you need to be able to solve difficult equations. There are some trickier ones, I will say, on there, but it's, yeah, I don't know. It's doable. It took me, this might be one of the longer tests that you guys write in this class, like just to be completely transparent. It took me about 8 minutes to make the answer key and confirm all my answers were right on Desmos and everything like that. So that's a little bit longer than the last couple, but as long as you're working efficiently, it shouldn't take you more than like 45, 50 minutes. Just as like a total heads up. Yeah. What else do you guys want to go over? Is there any other questions that were tricky or stumped you at all?
What about those like ratchet graphs to get like the x when kind of questions?
Okay, sure. So what those questions are going to look like is they're going to look like this. It's going to be a sign analysis type question. I'm going to just steal this exact equation and show you. So what it will look like is I will give you an equation and I will ask you to tell me where this is true. So we're looking at x squared minus 10x plus 16 is less than or equal to 0. So ratchet graphs are helpful sometimes. Other times they're not. This would be one of the ones where it's like, this isn't really that helpful to me. And the reason it's not is if you think about this graph, it looks something like this. It has a y-intercept of 16. It's all the way above the x-axis. So we don't really know when it's less than 0. You'd have to find the 2 points of the graph, probably here and here-ish, where the equation itself equals less than 0, even though the graph isn't below the axis at y. So to solve this, it's just factoring. So x minus 8, x minus 2 is less than or equal to 0. So in this case, ratchet graph, kind of helpful, but also not really at all at the same time. We get 2 solutions. We get x is equal to 8 and x is equal to 2. I personally prefer sign analysis when I'm doing these questions. I find it just easier to remember than the test points. Though for your test, so you know how we filled in all these tables? I give you like a sample table so that you can just copy and paste this and do it exactly as is on that test. So you'll see a table that looks like this. You can fill it in if you want, or you can do the sign analysis like I'm about to do here. So again, the idea of sign analysis is we want to know each of the individual brackets, what's going on at 2 and 8. And we want to see in these 2 regions here what's going on at that point. So for x minus 8, when it's above 8, it's positive. When it's between these 2 and between these 2, it'll be negative. You plug in like 5 minus 8, that's negative 3. So that would give us a negative answer. For x minus 2, it'll always be negative here, positive here, and positive here. And then all we're doing is multiplying these 2 signs to figure out that this is the answer of the parabola. And what you can see is it's kind of exactly as I predicted in between 2 points there. I was wrong about where the points are. It should be over to the right a little bit more. But all in all, it ends up being that as long as x is between 2 and 8, then we get a negative answer. We get it less than 0. The ones that those ratchet graphs were a lot more helpful for was like equations like this, where we can draw a really bad graph of it and we get the exact solution region. We just have to figure out the x-intercepts. This is one of those other ones, again, where not that helpful, doesn't really give us the correct solution as far as what we need to see. This one would be another one. It opens up, y-intercept at negative 12. So we know that the bottom region is going to be in the negative territory. Everything else is going to be in the positive region. So you can kind of see your answer before you even get there. But yeah. This one, ratchet graph, wasn't all that helpful for, but we still kind of know where our answer will be. I appreciate all the thumbs up here, Axel. What else do you guys need to see?
I didn't see any answer key for the chapter 8 review.
You're right.
So could you cover question 9?
Sure. The last word problem, let me guess.
Yeah.
Okay. Oh, that's the key. I don't want that. This is the one. Yeah, that's the one I want. So this one. You love your elimination questions, hey, Axel? Okay. 2 baseball players throwing basketballs back and forth, standing about 9 meters apart. Wow, I cannot draw a straight line on this tablet. That's not bad. Facing each other, each player throws a ball at the same time. In one exchange, the path of the basketball is represented by that equation. The path of the other ball is modeled by the equation. That in each equation, x is the horizontal distance a ball travels in meters, and y is the vertical distance traveled also in meters. Determine the point of intersection algebraically and interpret the solution. Okay. So if we're looking for a point of intersection, I'm going to spoil this question a little bit for you already. And what I'm going to do is cheat and show you what the answer should look like. So if we're looking for a point of intersection, we are looking for either an elimination or a substitution of these two equations. So there's that one. And here's the other one. Oops, I got the wrong thing. So when we look at these parabolas, there's one point of intersection that we actually care about. It's this one right here. This will be the answer. It'll be 3.75 for x and 2.938 for y, which is tragic because it probably means I have to quadratic formula this, which is a disaster. So I am going to use elimination to solve this. So nice, we don't have to multiply anything here. And I'm going to subtract the bottom equation. So nice, this cancels out this, and it cancels out this. Perfect. And then 12 minus 4 is 6x. Negative 28, this is negative 30. That. Did I do that right? Let's see. Looks that way. When you do that, you get x is equal to 5, which is not the case for the point of intersection. Interesting. Basketball players through the... Did I plug that in correctly? Yep, plug that in correctly. So x is equal to 5. So then y be equal to... So this would be y is equal to negative 25 plus 12 times 5 is 60 minus 28. So at a height of 7, these two will intersect. And then that would be it. So I guess at a height of 7, they would intersect. Yeah. Yeah.
Yeah.
Nice. Other questions that you two would like to see? Just so you know, the Zoom meeting will end in 2 minutes, but you guys can just like re-click the link if you want and hop back in. Ooh, I can't draw lines on this thing apparently.
I don't have any questions on my end.
Neither do I.
Yeah. All right. Well, great timing, you guys. So just a reminder, this is kind of what we're looking at for the test. So 2 multiple choice, 3 short answer for the systems of equations. So there's 1 word problem only. I'll throw this one in here for Azka and for Axel. There you go. It took me so long to type. That was embarrassing. And then linear and quadratic equations. So there's like 2 sections of the test. The second section, I got through the second section, this stuff, a lot quicker than I got through the first section. There is a few other things just to remember that, like when you're graphing, let's say like a linear inequality. So let's say you have like, y is less than 5x plus 1. When you go to graph it, remember that because it's less than, it's a dotted line. So you have to be careful with these symbols here, making sure that you're putting the right one. I put it as a multiple choice question on there just to like remind you that when you're doing it, like, oh, right, Mr. Nickel put this here to help us. And then remember when you're shading in a part of the solution, if you shade it in with a nice fun color, or if you like draw me a picture or something, it's always worth bonus marks if you get the region correct and are able to fill it in with a nice, lovely picture. Obviously, it'll be better than my little smiley face there. Axel Heisenberg would be greatly appreciated. Oops. Guess the meeting's over. But yeah, that's pretty much it. Hope you enjoyed my live stream with my 1 viewer. See you later.